With a drive to increase integration and system speed, minimizing power is emerging as a serious concern for FPGA designers. Lattice's ECP3 FPGA is the lowest power FPGA with SerDes in the industry. Designed specifically for wireless, wireline, and video broadcasting applications, the ECP3 operates at half the power and costs half as much as competing devices. Today, we'll be measuring the power of an ECP3 device, as well as looking at the Lattice power calculating software. But first, let's do a quick overview of these devices. The ECP3 is based on the industry standard LUT4 fabric with up to 7 megabits of embedded RAM, DSP slices with 320 18x18 multipliers, 800 megabits per second IOs with pre-engineered DDR3 memory interfaces, 3 gigabits per second SerDes, and a wide range of PCS-supported packet protocols. The architecture for the ECP3 has been optimized to minimize power consumption. The configuration logic, the LUTs, the EBRs, the routing, and the DSP blocks have all been specifically designed to minimize static and dynamic power consumption. Right now, let's take a look at the static power. Typical static power at 25 degrees C in watts is shown on the y-axis with the device density in thousands of LUTs on the x-axis. These are estimated values from the Lattice power calculator software. 70% of LUTs, registers, EBRs, and IOs are used. If we overlay static power for the Altera Stratic 2 GX and the Xilinx Vertex 5 LXT at similar conditions, we see that the Lattice ECP3 devices have up to 85% lower static power. Now, by adding a 100 MHz clock that will toggle the internal registers with a 12.5% activity factor, and considering a junction temperature of 85 degrees C, we'll see the estimated total power for these devices. We have conservatively assumed that a 6-input lookup table is equivalent to 1.4 LUT4s. The Lattice ECP3 FPGAs are still lower power than the competitive devices. Now we're going to look at a particular set of devices in this chart to see total power under various temperatures. We're measuring total power for the ECP3 95K LUT device. We're going to be doing this at room temperature, and we're using the same configuration, but this time we're going to apply a 32 IO stimulus at 100 megahertz. We're also connecting ammeters up to each one of the supplies. These ammeters are going to measure the VCC core, VCC IOs, and the VCC aux, which is your other logic in the part. We're going to take the measurements from that, multiply it by what the supplies are set to, and we're going to add those all up. That should give us our total power. In this case, that's 524 milliwatts. Using a real design with the same testing conditions, the power calculator generates the following curve of total power versus junction temperature. Now, overlaying our measured total power of 524 milliwatts at junction temperature of 32 degrees is very close to the calculated value, and most importantly, below the curve. Now we're going to be heating up the device for a junction temperature of 85 degrees C to get another data point. Again, we're going to take the current measurements, multiply that by the supply voltages, add them all up, and we'll get our total power. The power value is 758 milliwatts and is clearly below the calculated curve. Let's obtain one more data point at TJ near 50 degrees. We get 584 milliwatts. The actual total power measurements are a little below the power calculator curve. This accuracy allows us to use the power calculator to determine the power consumption of the device under a wide range of conditions. And the ECP3 remains the clear low power winner compared to Stratix and Vertex devices. We've used the power calculator to quickly and accurately determine the power. Let's take a closer look. The power calculator is a summary tab as well as individual tabs for each power component, such as logic blocks. In estimation mode, the designer can quickly obtain a total power estimate without a netlist. Simply enter your design parameters such as frequency, activity factor, number of LUTs, registers, and the tool calculates a total dynamic power. On the summary page, the tool automatically calculates the correct static power based on the device and package selected. Lattice's ECP3 is the lowest power FPGA with SerDes in the industry. Designed specifically for wireless, wireline, and video broadcasting applications, Lattice's ECP3 comes in at half the power and half the cost of competing devices. For more information, look us up at our website.